Whatever, this is chapter 2.2 till 2.4 course division. We can get it all done in one video. Anyways, basically differentiation. Now we're doing something called definition of derivative. Okay, we say differentiation. Differentiation, it means derivative. So when you see that word, don't get scared. It just means derivative. Anyways, so previously we know that deriving x squared will get you 2x. It's just a rule, right? But now they want you to use it using the definition of the derivative. Definition of the derivative means you have to use the rule. The rule of the definition of the derivative is as follows. If you don't know this, don't come to the exam tomorrow. Okay? Don't. Just go do the makeup on Saturday. Okay? What's the rule? Limit as h approaches 0, f of x plus h minus f of x over h. This, you need to know it. ماشي? Like need to know it. Type. It's called the definition of the derivative. So when they tell you definition of derivative, you have to use this rule. Type. How do we do it? What does it mean if I have f of 4? Incel prime. F of 4 means you substitute 4 as x, right? So when I tell you f of x plus h, that means instead of x, what am I putting? X plus h. So what do I like to do? Since if you just substitute everything directly, it's going to be so crowded. So I like on the side of the paper, I like saying f of x plus h equals, and I find it. What's f of x plus h? It means instead of x, what am I substituting? X plus h. So let's do it. X plus h squared, which is x squared plus 2xh plus h squared. Yeah? So now we can substitute that back in here. So it's going to be f of x plus h, which is this, x squared plus 2xh plus h squared, minus f of x. So minus, what's f of x? It's just x squared over h. What's very important is if you write it like this, you're going to get the whole question wrong. Why? Because since there's a limit, you have to keep on writing limit, then limit, then limit, then limit. So you have to put limit as h approaches 0. Please don't forget this. In the first periodic, so many people got their questions cancelled because they didn't write limit. Such a stupid reason to lose marks. Not even lose marks. They lost the whole question because they didn't write limits. That's how strict they are with this. Okay? So you have to keep on writing limits. X squared with x squared. طيب. Then here, can't we cancel h's? So to factor this out, you just say limit h approaches 0. Don't forget the limit. To take h out, we take h out. 2x plus h over h, which what? Cancels. Equals limit. Keep on writing limit. Keep on writing limit until you have no more h. Okay? Of 2x plus h. Then, can we simplify any further? No. So you put the 0 in. You get 2x. Because substitute h with 0, you get 2x. Khlas, you're done. Now you don't write limit because I substituted the h. There's no more h anymore. Okay? So this will get you a full answer. If you're in the exam, you should be able to predict what answer you're going to get. Because the derivative of x squared is 2x. So into the answer you should get after all of this should be the derivative. Okay? So that's how you can check. Let's do 10. G of x is 1 over x squared. Find g prime of x using the definition of the derivative. Sorry, in question 9 I'm not done. Because after deriving, they said find f prime of 4. So didn't we get 2x? So you need to find f prime of 4. So substitute what? 4. So you get 8. For question 10 now, I'm going to take it to a different page because it's so annoying working with no space. Okay? Anyways, you have this g of x, it's 1 over x squared. They're saying find g prime of x. They use the value of g prime of 1. Yalla, let's do it. G prime of x, yani, we want to derive it. How do we do it? Do we just derive normally? No, we have to use the rule. What's the rule? Remind me. Limit as h approaches 0. f of x plus h minus f of x over h. This is the rule, right? Yeah, so now you want 99% of the time, no, really depends on the corrector. To be on the safe side, instead of saying f, since they're saying g of x, just put g. Okay? It's not that big of a deal, wallah. But be on the safe side. So what did I tell you? Find them one by one. What's g of x plus h? It means instead of x, what am I putting? X plus h. Yeah, so 1 over x plus h squared. Right? Since I literally copy the same thing, but instead of x, you put x plus h. So this is what 1 over... Let's just keep it like this for now, because it's a fraction. Okay? g of x is just 1 over x squared and h. So we can now continue solving. Limit as h approaches 0, 1 over x plus h squared minus what? G of x. What's g of x? 1 over x squared over h. Perfect. Now can we subtract these two? We can't. We need to have same denominator. So what do you multiply by? X plus h squared here. And here what do you multiply by? X squared. This is how you make a common denominator. So it equals limit as h approaches 0, x squared minus x plus h squared over the common denominator, which is what? X squared, x plus h squared. I'm not going to teach you common denominator if you're in grade 12S. There's no need. This is just how to subtract fractions. All over h. Type. You need to expand everything out. So it becomes limit as h approaches 0. X squared minus, expand this, it's going to become x squared plus 2xh plus h squared. Right? Don't forget to distribute the minus. Over x squared, x plus h squared. All of that over h. Continue. X squared and x squared cancel, because x squared minus x squared. So you're going to be left with minus 2xh minus h squared over x squared, x plus h squared all over h. How limit, don't forget limit as h approaches 0. I'm still recording. Yeah. So now you need to figure out how do you continue simplifying this, because you can't we can obviously still simplify. Over here we can cancel h with h. How? Just factor it out, right? So it's going to be limit as h approaches 0, h out, so it's going to come negative 2x minus h over x squared, x plus h squared all over h. H and h cancel. So you're going to get, let's continue. Limit, I know it's a lot, اصبر. H approaches 0. Minus 2x minus h over x squared, x plus h squared. Now, can we simplify anything now? There's nothing to simplify. So it's going to be limit. Sorry, no, there's nothing else to simplify, right? So you just now, after, I told you, after you have nothing else to simplify, that's when you throw the h in. So it's going to become minus 2x minus 0 over x squared, x plus 0 squared. So it's going to become minus 2x over x squared times x squared is x to the power of 4. Cancel this x with this x. It becomes minus 2 over x cubed. This is how you find the derivative. They're saying g prime of 1. So what do you substitute? 1. So you have to go minus 2 over 1. So the answer is minus 2. Alright, now here, show that the function is differentiable. You're definitely going to get a question like one of these. Okay, I think it's going to be something like this. 14, I don't know, I feel like it's going to come in the written. But anyways, 11. Show that the function is differentiable at x equals 0. To show that a function is differentiable at x equals 0, two conditions must be met. Okay, and they're very strict conditions. The first condition, it must be continuous. The second condition is that the left differential is equal to the right differential. X, absolute value x. It's a bit annoying because you have absolute value. So the first thing you need to check, أول شيء, is let's check for continuity. Okay, as 0 minus and 0 plus. أول شيء, x absolute value x, if it was an actual function like absolute value x plus 2, when you see something like this, you'd have to split it into 2. X plus 2 and negative x minus 2. Or you could just say the negative of the first function. It's the same thing. But here we don't have that. We have x absolute value x. So it's so easy. The way they did it in the course division solution is they found the left and right differential without proving it's continuous. And that's wrong. You can't do that. Okay, you're not allowed. Okay, so let's take a look. Let's find that it's continuous. How do you figure out that it's continuous? That means the left limit must be equal to the right limit, must be equal to the value of the function at that point, right? So let's see. Limit as x approaches 0 minus of the function, so x absolute value x is equal to what? Let's take a look. It's going to be limit, substitute 0. It's going to be 0 times absolute value of 0 minus, okay, which is 0 times 0 is 0, right? طيب limit as x approaches 0 plus of x absolute value x. Since it's absolute value, it doesn't matter whether it's negative or positive. So 0 times 0 plus, which is 0. Are the left and right limit equal? Yes. Let's now check f of 0. So x absolute value x equals 0 times 0, which is 0. Easy. Type. So now we know it's continuous. You now want to check the left and right differential. Let's check the left differential. How do you do left and right differential? What's the rule? Limit as h approaches 0 minus is for the left, f of x plus h minus f of x over h. Must be equal to the same thing, but x approaches, it's always h approaches 0. Always, never h approaching any of them. Okay, always approaching 0. But since it's right, it's going to be 0 plus f of x plus h minus f of x over h. Let's find the left differential. What's f of x plus h? Let's see. F of x plus h, I told you, always find the first thing is f of x plus h. It's what? So instead of x, you have x plus h. So x plus h times absolute value x plus h. Right? So let's put it here. What is my x value? We're checking at what point? 0. So it's going to be 0 plus h, absolute value 0 plus h. Which is what? Isn't that just h absolute value h? Yeah. So it's going to be the left differential. We now apply the rule. Limit as h approaches 0 minus f of x plus h, we found it to be this, h minus f of x, which is what? X absolute value x, all over h. Type, let's do it. Is there anything we can really simplify here? Nothing. So let's do it. Limit. Sorry, no, when you can't simplify, what do? You substitute. Oh no, you can't. Wait, hold up. Okay, now I wrote this and I just realized that, okay, here I changed the x as 0, but here I kept the x as x, so that's wrong. I have to also put this x as 0. So let me go back a bit. Alright? This is the rule, right? Here we're talking about x as 0. So if you want to write this on your written part, you say limit as h approaches 0 minus f of 0 plus h minus f of 0. Because x in this case is 0 over h. So h absolute value h minus f of x, which is x absolute value x, but we're saying f of 0. So 0 absolute value 0, which is just 0 over h. Type, this cancels. This and this cancel. So there's nothing left to simplify. You're just left with h approaches 0 minus of absolute value h, which is what? What's absolute value of 0 minus? Isn't it just 0? Yes. Now let's check the right differential. So lim approaches 0 plus, for the right differential, f of x plus h will again be h absolute value h. We found it here, right? Yeah. Minus 0 absolute value 0 over h, right? So cancel, and then this with this, so you can get limit as h approaches 0 plus of absolute value h, which is 0 plus, sorry, absolute value, which is 0. So we just proved two things. What's the first thing we proved? That it's continuous. Well, the second thing that we proved is the left and right differentials are equal to each other. Now you can say continuous at x equals 0. So step by step, first thing you check, continuous. Find these three. Second step you check is left and right differential. This is the rule. But change x by what it is. In this case it's 0. So it will be f of 0 plus h minus f of 0. Okay, that's it. Let's do 12. Show that it has a vertical tangent. How do we show that it has a vertical tangent? So easy. Okay, to show that it has a vertical tangent, that means substituting this, you need to know. Substituting the x value into the left and right derivative will get you infinity. Well, they both have to be infinity. Either هيك plus infinity, or minus infinity, minus infinity. Why? Because vertical tangent, that means vertical line. Vertical lines have an infinite slope. That's why. So anyways, how do we show that it has a vertical tangent at x equals 0? Did they tell you use the definition of the derivative? They didn't tell you this, right? So you can just derive normally to find the derivative. What's the derivative of cube root of x? It's the same as saying x to the power of 1 over 3, which is 1 over 3, x to the power of minus 2 over 3, right? So it's going to be 1 over 3. X, you take it down, right? 2 over 3. This is your derivative. They want us to what? Substitute x equals 0. Let's find the left derivative with the right derivative. Shit. Here's the thing. You can just use this, but you're gonna get a normal derivative. But نحن to find the vertical tangent, you need to show what? Left and right. This gets you a normal derivative. And I need a left derivative and a right derivative. So can I use the normal old method? No. Okay, you need to find the left derivative. What's the left derivative? Limit h approaches 0 minus f of, in this, isn't it f of x plus h minus f of x over h? They want x equals 0. So let's say 0 plus h minus f of 0 all over h. What's f of 0 plus h? Let's write it on the side. Always, like I told you, write it on the side. So it's going to be a cube root of h. Right? Cube root of h. So let's do it. So it's going to be limit as h approaches 0 minus cube root of h minus f of 0. What's the cube root of 0? Just 0 all over h. Now, can you simplify these two? Yes, you can. It's h over h. You change this power into 1 over 3 all over h. Now, how do you simplify this? You subtract, right? 1 over 3 minus 1. It becomes 2 over 3. So where do you put the 2 over 3? Down. Now substitute 0 minus. You're going to get limit as h approaches 0 minus. Before I substitute, I want to change this into a radical. 1 over cube root of h squared. This step here is so important. Type. Now let's substitute 0 minus, because there's nothing left to simplify. 1 over cube root of 0 minus squared. Now, is this gonna get me positive infinity or negative infinity? What do you think? It's gonna be positive infinity. Why? 1 over 0 plus gets me positive infinity. 1 over 0 minus gets me negative infinity. طب isn't this 0 minus? How do I get positive infinity? Because it's square. Okay? That's the most important step. That's why I told you this step here is very, very, very important. Okay? So plus infinity. طب this is what? Left derivative. Let's check right derivative. Instead of h minus, we just do h plus. So it's going to get you the same thing. So you can just copy down most of the stuff. All over h, which is limit as h approaches 0 plus. Don't forget the limit, huh? You have to write limit. Cube root of h minus 0 all over h, which is limit as h approaches 0 plus of, let's just write, let's say you simplified it so fast, 1 over cube root h squared. You can just write this, they're not going to tell you, no. Okay, equals 1 over 0 plus squared all under the cube root, which is positive infinity. Now you say, left differential is positive infinity, right differential is positive infinity, so there is a vertical tangent. So therefore, vertical tangent at x 0. Got it? Easy. So now 13 is show that it's not differentiable at x equals 3. I just want to make sure that I'm not recording al fadi. Okay, yeah. How do you do it? Split it up into two functions, always. X minus 3, then negative x minus 3. Alright? This is for what? This came in the written, by the way. Once. This is for what? X to the right of 3. And this is for what? X before 3. This is greater than or equal to 3. Huh? Pay attention to this. Greater than or equal to 3, this is less than 3. Tamam. So the first step you did is you split it up. This is every time you get absolute value, you have to do this. Type. Then you can just follow the steps easily. Not differentiable at x equals 3. That means you need to prove two things. أول شيء, for it to be differentiable, it has to be continuous. If it's continuous, then the left derivative has to be equal to the right derivative. So the first thing you have to check is whether it's continuous. If you check and you see that it's not continuous, خلاص, finish there. Don't continue. خلاص, done. So let's check here. Is it continuous? Let's see. Absolute value of x minus 3. We need to find what for it to be continuous. Limit as x approaches 3 minus of the function has to be limit as x approaches 3 plus of the function has to be equal to f of 3. Nice. Let's check the left limit. How do we do it? We substitute into which one? Here. Limit as x approaches 3 minus. We're going to do which function? The one on... Sorry, no, not the one on top. 3 minus, yani before 3. So the one here. Okay? So it's going to be this one. Limit as x approaches 3 minus of what? Negative x minus 3. Which is, substitute 3, negative 3 minus 3, which is 0. Let's check the right limit. Which one am I going to choose? This one here. So it's 3 minus 3. Sorry, x minus 3. Then you say 3 minus 3, which is 0. So far they're equal. What's the last thing you have to check? F of 3. F of 3 is equal to... Which one do I substitute it into? First one. Because it's greater than or equal. So f of 3 is 3 minus 3 equals 0. So is it continuous? Yes. So do I stop? No, I have to continue. I have to keep on checking. Now I have to check the left and right differentiable. If they're not equal, and they're supposed to, because they're saying that you have to show it's not differentiable. That means you should get that these two are not equal. If they're not equal, you can say since they're not equal, then it's not differentiable. So let's find left differential. What's the rule? Limit as h approaches 0. F of x plus h minus f of x over h. In this case, what are we doing at x equals 3? So what are we going to change this rule into? Limit, sorry, this is 0 minus because it's left derivative. H approaches 0 minus. It's going to be f of 3 plus h minus f of 3 all over h. طيب. Now let's find f of 3 of h and f of 3 plus h and f of 3. Let's find it on the side. F of 3 plus h is what? Let's check. Which one are we going to use? Since we're approaching 0 minus, yani we're going to look at this one here. So f of 3 plus h, and instead of x, what am I going to put? 3 plus h. So negative 3 plus h minus 3, yeah? Which is what? Negative h. طيب. F of 3. What's f of 3? Which one do I substitute f of 3 in? This or this? Obviously the first one, because this is greater than or equal. So I have to substitute f of 3 here. F of 3 is equal to 3 minus 3, which is 0. F of 3 never changes, because it depends on the function. Okay? Now, let's continue here. Can we substitute everything back in? Yes. Limit h approaches 0 minus f of 3 plus h, which is negative h, minus f of 3, which is 0, all over h. This cancels. Negative h over h is what? Negative 1. It's not hard. Type. Left differential, we got it to be negative 1. Let's do right differential. What's the rule? Again and again and again. H approaches 0 plus f of... What am I going to do? Fast. You don't have to copy down everything. خلاص, you know it's going to be what? 3 plus h with 3. So let's do f of 3 plus h minus f of 3 all over h. Now, again, f of 3 plus h. Is it going to be the same? No, because we're approaching 0 plus. So which one I'm going to substitute 3 plus h? Here now. So it's going to be 3 plus h minus 3, right? This cancels. You're going to be left with h. F of 3 is what? F of 3 doesn't change, because the value of the function at 3 is always the same. Which one am I going to substitute it into? The first one, because this is greater than or equal. You can see the symbol, greater than or equal. Which is what? You don't have to do it again. I know we found this already, but just to show you. 3 minus 3 equals 0. Now, can we substitute everything into the rule? Yes. Limit h approaches 0 plus f of 3 plus h, which we found as what? H. Minus f of 3, which is 0. All over what? H. Cancels. This gets you 1. Are the left and right equal? No. So you go down and say left derivative is not equal right derivative. Therefore, not differentiable at x equals 3. Type 14. I think she's gonna get it tomorrow. focus now because I don't have a small feeling it's gonna come written. Anyways, this is nothing like you've done before, so you need to focus. They're saying given that this function is differentiable at x equals -1. So they're telling me it's differentiable. What's the value of f of -2? أول شيء f of -2 means what? The value of the function at, sorry, maybe f prime. Did they mean f prime? Because f of -2 means you just substitute -2 here. And let me check it up. Yeah, so f of -2, I don't know why I'd use this one, because -2 is before -1. So f of -2 means you have to substitute -2 here. So which is what? A times -2 cube plus b times -2 plus 11. So you get -8a minus 2b plus 11. Right? Now what's the problem here? We got a's and b's, bro. So we can't solve with the a and b. So what do? We have to find that a and b. Now, they told us something and they said that it's differentiable. So what does that mean? What are the two conditions that get me differentiable? 1, it's continuous. 2, left differential equals right differential. طيب, let's solve. أول شيء, for it to be continuous, what does it mean? It means the left limit is equal to the right limit. Yeah? So let's see. For it to be continuous, left limit equals right limit. Let's take a look. Limit as x approaches -1 minus of the function, let's say f of x, is equal to limit as x approaches -1 plus f of x equals to f of -1. Let's see. What's x approaches -1 minus? Let's take a look. What's the limit of the function at -1 minus? That means you substitute -1 here. صح? So let's do it. So limit as x approaches -1 into which one? ax cubed plus bx plus 11. Which gets you -a minus b plus 11. Alright? Type -1 plus, let's do it. So you substitute into which one here? So limit as x approaches -1 plus which one? -2. X plus 1, because we're going -1 plus, so it's the second function. So it's going to be -2 times -1 plus 1, which is 3. Type f of -1 is the same thing as what we just found now, but let's just do it to show. Where's the function equal to -1? On the second function, on the second equation, because they said greater than or equal. So you substitute -2, -1 plus 1. Okay? You get 3. Type. So we agreed that these have to be equal. So that means this here, -a minus b plus 11, has to be equal to what? To 3. So we're going to write that. -a minus b plus 11 is equal to 3. Let's like move stuff around. You're going to get a plus b is equal to 8. Okay? Type. Do I know what a and b is? No, but I got one equation. It's two unknowns. Can I solve two unknowns from just one equation? No. I need a second equation. So, I'm going to tell you now. Many people are going to do the left differential and right differential, and they're gonna go down they're gonna reach a stage where you have like 4 unknowns. It's unsimplifiable. So I'm telling you it from now. They gave you it's differentiable. So do you have to use the rule? They're saying given that is differentiable. So do you have to use the rule to prove that the left and right differentials are equal? To find the left differential and right differential, you don't have to use the rule because they told me it's differentiable. So I can just find the derivative normally. What's the derivative of the left? 3ax squared plus b plus 11. What's the derivative of the right? -2. So this is the second step. Very easy. We know we're talking about what? -1, right? So let me write this in a more organized way. Given that it's differentiable, the left derivative will just be equal to the normal derivative. 3ax squared plus b. Right? What's the derivative? This is just 3ax squared plus b. And the right differential is equal to what? -2. That we're talking about x equals -1. So you have to change this x to -1. So 3a times -1 squared plus b, which is 3a plus b. And this is equal to just -2. We're saying they have to be equal. So 3a plus b equals -2. Now we have two equations. First one and second one. A plus b equals 8 and 3a plus b equals -2. Everyone has their own ways to solve this. Really, everyone has their own way to solve this. People do it calculator. You can do it in calculator if you want. People just subtract these two equations. If it's in written, you have to show it how you did it, okay? And for me, I like subtracting, because when you subtract, these two will cancel. 3a minus a is 2a. b minus b cancels. Equal stays there. Minus 2 minus 8 is what? Minus 10. And you get a is equal to negative 5. But we still need b. So let's find b. We agreed that a plus b equals 8. So negative 5 plus b equals 8. So b must be equal to 13. So a equals negative 5, b equals 13. Are we done? No. They want f of negative 2. So that means you need to substitute negative 2 into the equation. Substituting negative 2 into the equation over here gets you in terms of a and b. But now since we found a and b, we can simply find it. So it's going to be negative 5, substituting negative 2. So negative 2 cube plus b, which is what, 13, times again negative 2 plus 11. I'm just substituting the values we got. We're saying x is negative 2, and we found a and b to be negative 5 and 13. Doing this on your calculator, you get 40 minus 26, which is 14, plus 11, 25. So the answer should be 25. Let's take a look. There you go. Okay, 15 and 16. I'll bet you both my hands that these are coming tomorrow. But I keep different numbers, but it will come. Alright? Let's first take a look at the answers. They said what? 3 and 5. So, let's see. So they're telling us this answer and this answer. Let's go through them one by one, and we're going to agree which one is which. Number 1. F of x is not differentiable. Let me zoom in a bit because it's too far when I'm kind of blind. Okay. 3 and 5 are the correct answers. F of x is 4x plus 1 if x is less than or equal to 0, and 3x squared if it's, greater than 0. Which is true, whatever. F of x is not differentiable at x equals 0 because f of 0 does not exist. Does f of 0 not exist? Take a look. F of 0 means you substitute x where? Here, because this is x less than or equal to 0. Substitute, you get 1. How doesn't it exist? Okay, this is wrong. F of x is not continuous, but is differentiable at x equals 0. Let's take a look. Is it continuous? Let's see. How do you check if it's continuous? If it's multiple choice, quickly, how do you check it? You have to check f of 0 equal to the limit as x approaches 0 minus equals the limit as x approaches 0 plus. 0 minus 0 plus. Yeah? Type. If it's computer part, quickly, what do? You just substitute 0 here, substitute 0 here, and check both. 4 times 0 plus 1, you get 1. 3 times 0 is equal to 0. So, f of x is not continuous but is differentiable. أول شيء 1 0. Does that mean it's continuous? It's not continuous. طب if it's not continuous, can it be differentiable? Never. I told you the two conditions for something to be differentiable are continuous and left derivative equals right derivative. But here it's not continuous, so how can it be differentiable? No way. Okay? So this is wrong. F of x is not differentiable at x equals 0 because it is not continuous. We just proved that. We said that we get 1 here, you get 0 here. So okay, it's not continuous. F of x is differentiable at x equals 0 because f of 0 exists. Is it differentiable? No. Now we're saying it's not differentiable. How can you choose 3 and 4? Here you're saying it's not differentiable, here it's differentiable. You can't choose both of them at the same time. You gotta pick one, bro. 5. Limit as h approaches 0, f of h minus f of 0 does not exist. Let's take a look. How do we do it? It's so easy. You just do it on your scratch paper. What's f of h? To do this, you have to do it. You don't even have to solve this. Wallah, you don't even have to solve this. How do we know it does not exist? What is this rule? What's this rule? This is the definition of the derivative, right? So, we agreed that it's not differentiable. So, will the definition of the derivative exist? No. Okay? So, that's why 6 is wrong. So, this is correct. 6 is wrong. Why? Because the definition will not exist if it's not differentiable. All you have to check, is it differentiable? If it is, then it exists. If it's not, it does not exist. That's it. طيب, هلا 16. Consider the function here. Same thing, select all that apply. What are the answers so we know what we're doing? 1, 3, 4. طيب, let's see. 1, 3, 4. طيب, which of the following is true? Let's check them one by one. You have 2x plus 1 if x is less than 0, x less than or equal to 0. And you have x squared negative x squared plus 1 if x is greater than 0. طيب let's see. f of 0 exists. Let's check. Does it exist? أول شيء man, without even checking, there's no reason for f of 0 not to exist. Is there any fractions? No. يعني it will always exist. But you know, don't do that in the exam. Actually check it. Let's see. f of 0. That means I substitute into which one? This one or this one? First one. Why? Because it's less than or equal to 0. You want to see where it's equal. So 2 times 0 plus 1, which is 1. Nice. So it does exist. The limit as x approaches 0 does not exist. How doesn't it exist? Let's check. Does it exist? How do you check if a limit exists? You need to check the left limit and the right limit, right? Let's check. Limit x approaches 0 minus of the function. Let's check it. We're going to substitute into this one, right? Because it's 0 minus. So it's going to be 2 times 0 plus 1, which is 1. Limit as x approaches 0 plus of the function is going to be, you substitute into this one here, 0 squared plus 1, which is 1. So does the limit exist? Yes, it does. So is it true to choose this? No, because we just found the left limit and right limit are both 1. Type the limit as h approaches 0 of f of h minus f of 0 does not exist. نحن, do we know if it's differentiable or not differentiable? We still don't know. We have to check it. Okay? We just figured out that it's continuous because we found that they're all equal. So what's the second step? You need to check if the left derivative is equal to the right derivative. I'm going to give you two ways to solve. Computer way, if it's computer part, and the second way is written part. Okay? Computer method. If it's a computer method, the left derivative derived normally. What's the derivative of 2x plus 1? 2. What's the right derivative? Negative x squared plus 1. What's the derivative? Negative 2x. نحن we're saying at where? We're checking it where? At 0, right? At 0. So you can't keep it in terms of x. So it's negative 2 times 0, which is 0. Are they equal? No. So does the derivative exist? No, it does not exist. Okay? This is the computer method to check whether the left derivative is equal to the right derivative. If it's computer, always do it like this. Derive normally and check whether they're equal. Written method. Written method, you have to check the actual definition. Limit as h approaches 0 minus f of x plus h minus f of x over h. Let's check. What's f of x plus h? In this case, it's equal to what? What's my x? It's 0. So it's f of 0 plus h. Since we're talking about 0 minus, we're going to substitute into this one here. So we're going to substitute f of 0 plus h. Yani it's the same as saying f of h. Yeah? Yeah? So f of h. What's f of h? And instead of x, what do we put? H. So it's going to become 2h plus 1. So f of x plus h, in this case, is what? 2h plus 1. Type, can we substitute? Yes, we can. No, we can't. Because, again, we're not working with x anymore, we're working with 0. So f of x, we're going to change it with f of 0. Again, why am I doing this? Because I actually want to find the value of the left derivative. So I'm doing it a specific number. They're telling me x at this point, so I have to change x with that. That's why it became 0 plus h. That's why it became 0 here. What's f of 0? 2 times 0 plus 1, we did it. It's already 1. Now, can we do this? Yes. Limit h approaches 0 minus 2h plus 1 minus f of 0, which is 1 over h. Cancel. 2h over h is what? 2. Tamam? This is what I did 0 minus, so that's the left derivative. Time to find the right derivative. Same thing, limit h approaches 0, what now? Plus f of, I'm not going to write x plus h and x again, I'm just going to say 0 plus h. You already know why, we figured out why. Over h. Yeah? Yalla, let's do it. So it's going to be f of 0 plus h, since we're talking about 0 plus, we're substituting it into the second one. Okay? F of 0 plus h, and it's the same thing as saying f of h. So it's going to be negative h squared plus 1. So it's going to be negative h squared plus 1. Limit h approaches 0 plus negative h squared plus 1 minus f of 0. Again, we already found out what f of 0 is. F of 0 does not depend on 0 plus, does not depend on 0 minus. It depends only here, whether it's where the less than or equal is, where the greater than or equal is. Where is it? It's here. So it will always never change. It will never change. It's going to stay the same all the time. So it's going to be 1 over h. Cancel, cancel. You're going to get h squared over h gets you limit h approaches 0 plus negative h. Substitute, you're going to get 0. I got 0 here. I got 2 here. Are they equal? No. This is the written part method. So therefore, it's not differentiable. Tamam? Okay. So we did 1, we chose it. 3, we chose it. 4, we're going to choose it. Why? Because it is continuous. We figured out it's continuous. 1, 1, 1. Is it differentiable? No. We just proved it why in both methods, the computer method and the written part method. Okay? فهيك we finished 2.2. If you're watching this, thank you so much for watching. Good luck in your exam.